Hello, guys. So this is our Thursday lecture. So I'm gonna cover in this lecture the C programming basics, the most important stuff that you should know about programming in C, or the stuff that we're gonna see in our programming of the microcontroller as we go on in our course. So let's go forward. So here is the outlines that I'm gonna cover in these presentations: the variables in C, the functions in C, the flow control statements like if statements, while loops, arrays, and how to deal with them, structs, which may be new for some of you, but we gonna see them heavily in our course. So I'm gonna cover them in here, and finally something called pre-processing. Okay. So let's start by variables. So basically here are the key variables or variable types that you're gonna use in our course, okay? And this is very important because choosing the variable types carefully will save some space in the memory, and this is very important in microcontroller programming. So for example, the first one is called unsigned char. Okay, if you define a variable as an unsigned char, you can put anything in it, but the value shouldn't exceed 255. Okay, because it's only 8 bits. 8 bits. So an 8 bit, if all of the 8 bits are one, this is 255. Otherwise, you will have overflow. So, but at the same time, you save space because you only have 8 bits in the memory to store the value for this variable. Okay. Another observations that I'm gonna highlight here is that there are some additions done to the basic C language, and our versions that we're gonna use is C, or our compiler is support is C99. Okay, nothing major changes. Just here is some of the variable types have other synonyms we can say. So you can write in your program unsigned char I equal to 0, for example, or unsigned 8 underscore T. The good thing about these namings from C99 is that you're gonna have an idea what is the number of bits that this variable will have. So for example, here the unsigned char, while you cannot guess that from the name in C, but you can guess it from C99, just 8 bits. Here, for example, int 32 or integer 32, you can't say if long is 32-bit or not, but you can say from this name. Okay. So as you see here, we have signed, unsigned variable types, and signed variable types. Okay, and for the signed variable types, we can cover now both negative and positive, but at the same time, we reduce the range. So the range here was from 0 to 255. Now it's from minus 128 to 127. Okay, we have also unsigned short, and the short, which is unsigned integer 16-bit and signed integer 16-bit. Okay, we have also two options, you can say. I don't know why they have two options, but if you have a 32-bit unsigned integer, you can define it either using unsigned int or unsigned long. Both are 32 and both are unsigned, and you have the same range as you see here. And again, if you have 32-bit integer that's signed, you can define it as int or long, and both again is 32 bits and cover also the same range of numbers. Okay. Finally, you have also float, which is 32 bits, and double, just to if you have a float number or double number or real number, we can say like 1.1 or something. Then you need, of course, bigger space because now you have to store the decimal value and the number after the decimal point. Okay. Now let's see or discuss more about the sign, because this is a regular error that many people do, including mine, that you define some variable, some range, then you have difficulty, understanding what kind of numbers is there. And also especially for negative numbers. So first, most compilers use two's complement to represent negative numbers. Okay, something called two's complement. Just search Google for it. It's very easy. Okay, to understand. So you noticed, guys, that if you have an unsigned number, you have the range from 0 to 255, but now it's minus 128 to 127. So let's see how is this happening exactly. So, for example, if you have assigned a number with y, we need, so these signed numbers or signed binary numbers, we need the last, bit number 8, for example, here, is to define the sign of the variable, either positive or negative. Positive numbers, you will see that they always have 0 here. Negative numbers, they always have 1 here. Okay? So let's see. So for positive 4, it's easy. So just a 4 and be sure this is 0. Okay. And for negative 4 now, it's a complication. It's because of the two's complement. So to represent 4 minus 4 as two's complement, we write it in that way. So just Google it. It's easy again. Okay. So and as you see here is 1 at the end. This means it's a negative number. Okay. So 127, which is the maximum range here, is represented using this value. Clear? Okay. But minus 128, which is, as absolute, the maximum negative number that you can get is 1 and 7 zeros. 1 and 7 zeros. Okay. So this is basically, and by the way, if all the digits are 1, this is 0. The two's complement of that number is, is 1. Okay. So that's why we have, less range in the positive, from 255 to 127. This is because the last bit. Okay. Okay. Overflow and underflow. This is again a problem that people might go through. That they assign a value to their variable, but then they see different values rather than the ones they define for this value. So let's see. For example, if you define a variable called I as an unsigned int, so it can take values from 0 to 255. But not what happened if you exceed 255. Okay, so basically here I is 255, then you increment I by 1. If you look at the debugger in our microcontroller, you will find that I will be 0 because overflow happens, because you can't store 256. You will go rotate and start counting again from 0. And I will give you some quiz or homework, whatever. Is that how to just give us example about the underflow. It's really easy. Just look at here, okay, and you can guess some example, and you can search Google, of course. Okay. People might say, okay, to avoid overflow, we might define the variables with bigger range, like for example using double, or maybe define all your variables as double. Yeah, this might be okay for microprocessors, but for microcontroller it's not, because microcontroller usually very limited in memory. Okay, so you must be wise all the time, especially with large complex programs that you are not consuming much of the memory of the microcontroller. Okay, so the advice here is is you just choose the perfect fitness, okay, for each variable. If you know that, for example, I will not exceed 8 bits, then choose unsigned char for it. Okay. Variable scope. This is also very important because you might define a variable somewhere, and when you use it somewhere else in the program, a compiler will give you an error. And this is because there is a scope for each of visibility for each variable. Okay. And the location of the variable determines the visibility of the variable. So for example, here we have two functions, the main function, of course, and we have the, another function called the hello world. Okay. And as you see here, each one has a variable called I, but they are different because this I, for example, has a scope of only hello world. Okay. So it can't be visible out, anywhere else. And this I it's another just another variable, it's another address in the memory, and its scope of visibility or usage, we can say, only within the main function. And they are different, although they have the same name. Okay, so it changing this will not affect this. It changing this will not affect this because again, yes, they have the same name, but they are in different locations in the memory. Okay, and they have different scopes as well. And these two variables, which have the same name I, are local variables. So we define them as local variables because they have only local visibility, not global one. But how about global variables? Yes, there is global variables. So for example, int j equal to 0, this variable j is defined outside the main loop and outside, it's not defined in a function. So it will be visible inside the hello world and also inside the main function. This is called why it's called the global variable. Just to highlight something in here as a best practice to use when you code, we oftentimes need global variables. That's fine, but remember, if you have a global variable, you might by mistake somewhere change its name. I'm sorry, change its value, and cause some error. Okay, so it's always good practice to minimize the use of global variables. Okay, to avoid such errors. So let's go to functions now. So first thing we need to know what the function is. Just a piece of code. It says own scope visibility, and it can be called from other functions as well. Okay, and it makes our code more more readable, we can say. Okay, so a function usually needs an arguments and return value. Okay, might need. It's optional. Both are optional. Okay, so first, what is the arguments? It is the thing that we send to the function to use, some variable we send. Like for example, in here, this is a function called hello world no return. Okay, it needs a variable to be sent to, which is k here. It's called k. Okay, but it's optional. You may find functions that has no return, like no argument, like this, for example. A function also might return something or might not. So, for example, here this function return an integer. So return k plus for example, it receives the k, so it has an argument as well, and receives and sent back the increment of this variable. Okay, and you might see even function with no argument or return, like this one, for example. Okay, function prototype. So basically, the compiler compiles or translate the program sequentially. Okay, so let's go for a bad case or a failed case here. So here we define the function called hello world after the main function, but in the main function we use hello world. So when the compiler reaches this point here, he will just confuse. Where is his hello? It's not defined. He didn't know it yet. Okay. So we need something to tell the compiler if you're gonna put the function of the function body after the definition, after the main. If you're gonna put this function hello world before the main, it's fine. You don't need these prototypes. But in that case, we need something to define this hello world keyword to the compiler. So here we put it. This is called prototype. So the function body is after the main. For some reason, you was forced to do that. But again, if you put the function body before the main, you don't need the prototype. But here, for some reason, you put your function body after the main. So you need something to tell the compiler that there is a function. Look for this somewhere in the program. So we put this line here, which is just this line, but with a semicolon before the main, so that we can call safely hello world from the main. So this function just tells the compiler, oh, there is a function called hello world, just go and search for it. Flow control statements. So we need flow controls, all the time. So the basic, two kinds of it is conditional branching, we can say, or conditional expressions. And for that case, we use if else or switch statements. And most of the time, just if else. Okay, don't bother with switch. And for repetitive statements, we might use while loop or for loops. Okay, and for both we have some conditions to satisfy, so we can branch or make the loop. Okay, and here is all the operators that you're gonna use, that you might use in your program. So for example, the logical operators like logic or, logic and, logic not, you can use these symbols. Okay, equality like equal or not equal, these symbols. Less than, greater than, less than or equal, all that stuff. The relational operators, and here are those symbols. So microcontroller in specific, we need the program to run all the time. Okay, so we need all the time infinite loops. Okay, so the infinite loops, just the basic thing, just while one, which is just like while true. Okay, because any digit, any number rather than zero is considered true. For example, here while one, do that stuff. Okay, so it will run forever. While minus 21, that's very fine. That's minus 21 is also true because it's not zero. But while oh, I'm sorry. Yeah. So, but if you write here while zero, it will not, of course, it will not, because it's false. So it will not continue. Okay. So don't use zero. You can use anything as true. You can even write, no, not write your name. It will not be considered. Yeah, it will be considered an error. Okay, now what if you wanna break this infinite loop? So the basic stuff you use break. Okay, and we oftentimes may need it. Okay, so we just use break like this. Arrays are very also important. Okay, so arrays is just a container, we can say, for many or multiple values or variables, but all of them has the same type. All of them are integers or float or double, whatever. Okay, so to define an array, you have many ways. Define and initialize, of course. So, for example, you are defining an array, but you didn't initialize it. So, what happens in here? The compiler will book 6 places in the memory. Each place is a 32-bit because this is an integer or 4 bytes. Okay. Here this is another example. Here you define, and when you do this two parentheses, this means initialize all the locations, the 6 locations to 0. Okay, and here this is a real initialization. So here you define an array. You didn't put here a size because the size will be implicitly known from the number of elements. So Here basically a 5 locations is in memory will be reserved for this variable called array called data or variable. Okay, the first location will have a value of 1, then 2, 3 until 5. Now, how to access an array? This is easy. We use these brackets. So, for example, if you define an array with 4 locations and you want to access or change or use the first location value, the first location has a number of 0. So, location 0. Okay. The last location is equal to the size of the array minus 1. So, the last location is that of 3 in this case. As I said, arrays in memory are allocated, as a chunk. So all the locations will be beside each other. So here, if you define this variable data in that as an array like this, it will have 5 locations, something like this. And any location in the memory has an address. So let's assume that the address of the first location is 0. Then the address of which has 1 now as a value. The second location will have a very address of 4 because basically this is int, so it's 32 bits. So you have 32 bytes, 32 bits or 4 bytes, 4 bytes. So your memory is byte, 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 byte. Bytes on top of each other. So if the first byte has a location of 0, the second is 1, third, second 0, 1, 2, 3. Okay, then the second location or the 5th byte, okay, will be 4. And this location will have value of 2 and so on. Now, if you want to pass the array to a function, like just an argument for the function, okay, you sent it very simply like this. But basically, what's happening in here, only the address of the first location, which is in that case, for example, data 0, will be sent to the function. Okay, and when we receive it, we do it in that way. This is called the pointer. So it's pointing to the address of the first location of the array. So for example, in here, when you do that, then you take this and you just make any normal operation, array passed of 0 or 1, whatever, and change whatever you want. But of course, any change happens here will affect the original version. So for example, array passed here initially has 1, 2, 3, 4, 5. So location 0 has 1. When you send the array to this function in here, okay, then you change the first location to 10. Now this array has changed. So both will change. So now first location has 10, not 1. So be careful on that because this is different from functions. From normal variables that is not arrays. This is wrong. Sorry for that. The copying array. I'm sorry. So if you want to copy an array to another array, if you have 2 arrays, like for example, array 1 and array 2, and you wanna copy what's in array 1 to array 2. Where is laser? Yeah. Okay. So you can do it like normal variables like this. So this is wrong. Okay. But we have to have a loop, and you must loop over all the elements. So like something like this, and you must access element by element. So that's an annoying thing about for arrays really. Structs or structures are also very important, and we're gonna see a lot in our course. So you must be, you must know them very well. So a struct is just like an array. It also a combination of elements. But now these elements can have, different types. In arrays, all of them is integer, all of them, float, but here you can have different types. For example, here we are defining a struct called car details, okay, which have three elements. One is integer called mileage, another is char called color, and another is array, char array called make. Okay, so basically, this is actually this example is good because it gives you an idea about the context that you're gonna use a char. For example, if you are defining something by many parameters or something that has many parameters and all those parameters are independent or not related. For example, like a car here, its mileage is integer, it's a number. Its color, for example, if you define the color by one letter, like R for red or yellow, Y for yellow, and so on. So it's a char, it's not integer. The make is an array because you have to Toyota, for example. So Toyota. So this is an array of chars of characters. Okay, so you have different types, variable types that define something, one thing. Like for example, a student, he has a name which is string or an array of characters. It has age, which is integer. It has grades in that course or that course. Again, another integer, and so on. So when you have this situation, you use a struct or structure. Okay. So here, an example, we have here a structure with these three elements. Now, in the main function, you can access first. You can define. So you have here when you define a struct, it's like you are defining a new data type, something like integer. Okay. Now, when you define a variable for that from that type, you use that expression here, struct, then the name of the struct, then car. So car1 now is of type car details, which is a struct. Okay, it's really complicated. So, but this is just you can imagine it as a new type, array to C, something like integer or float or whatever. Okay, so here we are saying that car1 is a variable. Its type is car details. But what is car details? Car details is another variable, but it's of type struct. Okay. So at the end, the car1 is just an struct. So when you access car1, for example, is my car. Okay. So for example, so my car has a mileage. When you access an element or a variable inside you use this dot. So car1 dot mileage is equal to 100. Car1 dot color is R. Then there is the make Jeep, for example, car1 dot make of 0 J, car1 dot make of 1 is E, and so on. Your car, for example, car2. So struct car details car2. Car1 dot mile, car2 dot mileage, 90. Car1 dot car is, blue. Car2 and car2, not car1. Car2 dot make, maybe your car is Fiat. Okay, so car2 dot make of 0 is F, 1 IAT, that's the context or an example of using structures. Now, how to parse a struct to a function? Okay, it's similar, a little similar to function to arrays. We send here again an address to the first location of the struct. So when we are using the ampersand, this one. So it's exactly the same example, but we added here another function, and we send the address of this struct to this function. And when we receive it, we did that in that way. So we put struct, then the name of the struct, the definition, car details, and you can change this, by the way. You can call it car2, that's fine. Okay. Now you can access any one of those inside. But when you access it using, this is called a pointer now. You should use this I don't know what they call it. You know, this side. So it's dash or minus and the arrow, the right arrow instead of dot. Okay. Finally, the pre-processing or preprocessors. So we always talk about compilers. Okay, and compilers take the C programming that you coded and convert it to assembly. Okay, then another stuff or program is called assembler, takes the assembly language, the translated assembly language, and convert it to binary. So it's a two-step process. But actually, there is another process called pre-processing before we get to the compilation. So you start. This is your code. Let's assume it's your code is in a file is in a file called the file.c. And for example, this file has some comments. We always put comments. Okay, so there should be this comment is just for you, not for the compiler. So there should be a way to remove this comment, and this is the job of the preprocessor. It's another stuff, another program, okay, that takes your file and removes these comments, and actually do another thing. It handles what's called preprocessor directives, and I'm gonna talk about one of these directives, which is the hash define statement. Okay, so for example, let's assume we have 8 arrays here, and all of them of the same size. Okay, and the size is 6. So you can just write int array 1, 6, 6, and all of them are 6s. Or you can do it elegantly. You can, use this hash define size 6. So now this size now is just, you can consider it as just a synonym of 6, something like this. So the preprocessor, when it receives its file, your file, it will change all the instances of the word size to 6. Now, someday in the future, I wanna change this. If you didn't use this line and you just hard coded it in the program as array 1 of 6, array 2 of 6, and so on, you need to make 8 changes. But with this pre-processing stuff, you hash define, you can just make one change in that line and don't bother again about any instant somewhere. Especially if you have a very complex code, very long code, okay, just one change will change in anywhere else. And this is what the preprocessor is doing. So whenever you give it the program like this, it will remove these sizes and just put 6 instead. Okay. Okay, thank you very much. This was my Thursday lectures. I hope you study it or at least read it, because we're gonna need many of the definitions and the stuff in this lecture in our microcontroller processing. Thank you very much and have a good day. Bye bye.